So in the previous video, we used the Create Plan feature and discussed this feature in detail. Recall that the plan is created by turning all randomness off and creating a deterministic sample path by simply running one replication of the Simio model. So we should consider this an optimistic view of what could happen when we run the system. Of course, when we run the real system, or when the real system operates in reality, there is randomness. So this randomness occurs in process times, setup times, machine failures, and so on. And so when the random events do occur, they quickly make the deterministic plan invalid. And that's where the Analyze Risk feature comes in. The Analyze Risk feature essentially turns randomness back on and replicates the model to try to estimate the probability of meeting the targets. And so when we run the Analyze Risk, in this case I ran for 20 replications, and we can see on the markers on the entity workflow view now have our estimates of the probability. And so for example, this 79 represents our estimate of the probability that order 0001 will meet its target ship date based on the 20 replications that we ran with the randomness turned back on. And these estimates are based on a confidence interval on the proportion of replications in which the job met its target. And so we can control that by both the confidence level. We could increase or decrease the confidence level, or we can increase the number of replications. So for example, if I change from 20 to 50, we see immediately that the model has changed, so we're warned. We can then click on the Analyze Risk button again, and it will then go run the additional 30 replications and report the confidence interval, or report our estimate of the probability based on the confidence interval. So the Gantt chart here is still a view of our deterministic plan, and now we've augmented that with these probability estimates based on replicating the model with randomness turned on. So let's see how we might use this Analyze Risk functionality. And so I've reset the model back to its previous state. And so the first thing I'm going to do is create the plan, and then I'll go in and analyze the risk based on 25 replications. So I can also expand the table view and see my probability estimates in this form also. And so we can see I have several jobs which are problematic, less than we expect them to be late, and we'd like to try to fix that situation. So the first thing I'm going to do is go to my resource plan and see if I can try to figure out what the problem is. If I click on the operator and look, one thing that we see under the constrained entities is that there are many of our orders that are constrained waiting for an operator. So one easy thing that we could do is let's add a second operator. So if I go back to the facility view and the properties, we have a reference property for number of operators, and we'll just change that from 1 to 2. Then when I go back to my plan, I can then reset, create the plan, analyze the risk, and see the net impact of adding that second operator. We can see that adding the second operator has improved the situation. We have fewer red jobs, or jobs that are in danger of being late, and a couple of our previously red jobs have now turned yellow, meaning they have a higher probability of being on time, but there's still a concern. Another thing we can easily do is we can change the queue ranking rule for our workstations. So these are set to the default first in, first out. We can easily change that. Let's do smallest value first and set that to orders due date, meaning if there's a queue of jobs waiting for the station will choose the one that has the earliest due date. So we would expect that to perform a little bit better in the case where we have queues of jobs waiting to be processed. So we can go back and reset, create our plan, analyze the risk, and our jobs have changed a little bit. You can see that we've reduced the number of red jobs further, but it also looks like we've increased the number of jobs that are yellow. So one final thing that we'll try for this model is to increase the availability of our resources. So if we go and look at our schedules, again, we have a standard work week where we have standard work days from 7 to 4 with an hour for lunch. Suppose we added an overtime day. So let's say overtime day. And in our overtime day, we're going to add a 4-hour work period at the end. So I can do my 7 a.m. 4 hours like we had before, 12 p.m. 4 hours. So this is our standard work day, and I will add to that, let's say 5 p.m. 4 hours. So we're adding a 4-hour overtime period starting at 5 p.m. and then we will create an overtime week, and instead of having standard day, we'll have overtime day. And we will apply that schedule to all of our resources. So we're going to say the operator will work overtime, as will our 4 workstations. So we change all of those to overtime week. Go back to our planning tab, create the plan, analyze the risk, and we can see that our target ship dates are met in all cases except one, down here order 13. And we can see the problem with order 13 is that it spans this weekend. So we could go back in if we wanted that to be on time and add a weekend shift for the weld and the operator if we wanted to. And there are also several other things we could try in order to improve the system performance. But the basic idea is that the risk analysis and the RPS functionality lets me experiment with different alternatives. When I'm satisfied with the alternative that I chose, for example, this overtime week, I can then use the create plan feature and go back to our results. For example, if we look at the dispatch list and other reports that we could use to operate the system. And so in this example, what we've done is we've used a Simio model to do the system design. So we did the capacity analysis and so on. We then made some minor modifications to use real orders and to start the system not empty and idle that would be indicative of a real system. And then we used the RPS functionality to develop an operational plan and then create dispatch lists that we can actually operate the system using.